Welcome. This is video number 2 of section 8.3, rational functions. In this video, we're hoping to accomplish a couple things. First of all, to show you in a rational function how to find, if any, the horizontal asymptotes, the ones going horizontally across. And then we're going to show you how to actually graph pretty complicated rational functions with your graphing calculator and show you what my expectations will be for you when it comes to calculating things out on your paper. But first, we better talk about horizontal asymptotes and a little list of rules here that we follow. As you can see here, and you can read this with me, this is in your text also right here. It says to find horizontal asymptotes of a graph, a rational function, compare the degree of the numerator, m, so they're saying m is on top, with the degree of the denominators, n. Now, we should probably talk about what a degree is. If I have a term that's 3x to the second power, 2 is our degree. If I have a term that's 10x to the fifth power, 5 is our degree. Now, if I add other terms on, the degree is simply the highest exponent, so it'd be 2. Here, if I add another term on, it'd be 11x to the 6th. Now I've changed my degree to 6. And keep in mind that if you have two variables in one term, you need to add the exponents together to find a degree. So that has a degree of 2. So hopefully you remember that from Algebra 1. That's a quick lesson on degree. Now, if you understand that, it's pretty simple to find horizontal asymptotes. But you can look here, and we'll use this little chart here. And you should have this in front of you at all times because it helps. First of all, number 1. If you look at number 1, the degree of the top is 1. These are degrees now. And that's simply the exponent of x in this case. The degree of the bottom is 1. Now this is 1. Any constant is the degree of 0. So they're the same. So m is equal to n. Okay. So we're looking at number 3 here. If m is equal to n, the graph has a horizontal asymptote, at y equals a over b. Now, when they say a over b, a is the coefficient of the term of the greatest degree, okay, in the numerator, and b is the coefficient of the term of the greatest degree in the denominator. So in this case, we're talking about 2 and 1. So if we put 2 over 1, we get our horizontal asymptote. This particular function has a horizontal asymptote at y equals 2, and it's there simply because your degrees are the same, and your a over b is 2 over 1, which is 2. Number 2, as you can see, our degree in the top is 1. Several terms here. The highest exponent is 1. That's your degree. The bottom is 2. And in this case, m is less than 2. So number 2 qualifies, and it's so therefore, I'm sorry, the first one qualifies. M is less than n. So let's rephrase that. I'm looking at 1 on top, 2 on the bottom. M represents my top value. N represents my bottom value. So m is less than n. If that's the case, then this rule applies. Your horizontal asymptote is at y equals 0. Okay, so it's pretty simple once you get the hang of it, how to determine these asymptotes. Now, the next one, as you can see, m is greater than n. The degree of the top is bigger than the degree of the bottom. If you have that situation, then number 2 applies. There are no horizontal asymptotes. And you would write that in there. No horizontal asymptotes. No horizontal asymptotes. And number 4 is the same way. As you can see, m is greater than n. The degree 2 is bigger than the degree on the bottom 1. Therefore, there's no horizontal asymptotes there either. So 3 and 4, the second applied. And then we're looking at number 1. If they're the same, then a over b, which would be these two, would be your horizontal asymptote. And if the bottom one's bigger, then y has to be equal to 0 as your horizontal asymptote. So that's how you determine, and you'll get used to this, and it's really not too bad once you get the hang of it. Now, The next phase of this video is we're going to start graphing. And get out your calculators at this time because we're going to need them. Now, I've given you a list of rules here to follow, and we're going to actually apply them to this equation, this rational function. Y equals x squared plus x minus 12 over x squared minus 4. There's 4 things we're going to do. We're going to ask you to do. First, simplify the equation. Well, this is already simplified. You want to multiply everything together that you can. You might have to FOIL, you might have to distribute. Just make sure you multiply everything you can. Then so that's done. Step number 2, identify the vertical asymptotes and holes by finding the excluded values. So we're going to find vertical asymptotes and horizontal asymptotes. In this setting, as you can see, let's find the horizontal asymptote since we are fresh off this determining that the m is equal to n, right? Because our degree of 2 is equal to the degree of 2. So then our coefficients of those terms are 1 and 1. We put those over each other, and that becomes your horizontal asymptote. All right, so we could draw that right in here, right across here at 1. Y equals 1. That's one of our electric fences in this graph. So hopefully that made sense to you. Just use the rules above. Now the vertical asymptotes can be found by setting x squared minus 4 equal to 0. This one can be factored. Think back to chapter 4 now. We're going to have to factor in this unit. In fact, we're going to get into a lot of factoring, so it might pay off for you to actually review some of the factoring skills in chapter 4. So we're looking at 2 and negative 2. X is equal to 2 or negative 2. So this one has actually 2 horizontal vertical asymptotes right here. Okay. And right here. So you can see it's subdividing our graph into several regions that we're going to find the graphs for. And eventually we're going to turn you loose on the calculators here. But the last thing I want to find are the x and y intercepts. I want to kind of get an idea where these graphs are going to cross. The easiest one to find of those two would be the y-intercept. So let's label that y-intercept. And we know that y-intercept exists when x is 0. So if we do the y-intercept, y is equal to 0 squared plus 0 minus 12 all over 0 squared minus 4. And convenient, all these terms disappear, and you're really only left with this. So the y-intercept's 3, or 0, 3 if you prefer. So that's the y-intercept of one of our branches of our graph. The x-intercept looks like this. Let me just erase this because I'm running out of room. So hopefully that made sense to you. Make sure you write that down. In fact, I'm going to erase, let's just erase, I'll leave that there. So the x-intercept is when x is 0. Or actually when y is 0. So we're looking at the x-intercept, and we know that exists from past when y is 0. Now, the question here remains, if I look at this equation and put 0 in for y, what will turn this function, x squared plus x minus 12 over x squared minus 4, what's going to turn that into a 0? Well, the only way that's going to happen is if we somehow turn the numerator into a 0. And I think there's a couple of ways we can do that. So let's do that up here since we got space. I'm going to factor the numerator into 2 binomials, x plus 4 and x minus 3, and set it equal to 0. I know that if 0 is in my numerator, then it's going to be equal to 0, and that's what I want. So it's easily factored, so we get 2 answers, negative 4 and 3. Those are my x-intercepts. So I know my graph's going to cross at negative 4 and a positive 3. So those are just a couple key points that you can plot. Now the rest of the work can be done with your calculator. What I want you to do at this time is type this in to your calculator. Make sure you enclose everything in parentheses. And the calculator will actually sketch the graph. So I'm going to give you time to do that. I'll pull up my calculator and show you what it should look like when you're done. Okay, welcome back. You can see I've got my calculator all set up, ready to go. I basically, what I did was I typed in y equals, I typed everything in, as we said, x squared plus x minus 12 divided by the other binomial. And then if I want to know what that is, I can scroll over, I guess. And it will show me, I hope, because it cuts it off because it's so long. There it is, x squared minus 4. And then if you hit graph on your calculator, mine looks like this because I've set my windows with a -8 to +8 on both settings. It works pretty well. And so when I hit graph, you can see we've created 3 branches. And you can see also that we've got asymptotes at -2, 2, and there's also one at 1. So what you can do, if I ask you to sketch the graph, is I will let you then use, once you found the x and y intercepts, use your table of values to help you plot further points. The calculator will do that, and that's in the table feature. Notice that -2 and 2, there's errors because those are vertical asymptotes. And then the rest is up to you. Just plot enough points to get the full picture like it is down here on my screen. So that's how you graph rational functions. You basically make sure you simplify it, find out horizontal and vertical asymptotes, and then find the x and y intercepts, and then the rest can be done with your calculator where you actually find points that basically will work for you, and plot them. So good luck with this. Hopefully that made some sense, and good luck with this, and let me know if you have any questions. Now we have one more video left, and then we'll wrap this lesson up.